Okay, let's talk about Girsanov's theorem. Girsanov's theorem, to my opinion, is a probabilistic way of looking at a change of reference frame. So imagine the probability of going x through a trajectory x naught to xn. We can divide it into going from x naught to x1, and then from x1 to x2, so on and so forth, up until xn. So in shorthand, you can just compound it to multiplication of all of them together and assume each one of the small steps is a Gaussian, is a Brownian motion. And so one can express such a process as this. And you multiply ti plus 1 minus ti as on both sides. We know that this can be equivalent to a degree of velocity. And for in physics notation, a dot is a time derivative of time. And assume each time slice is a constant dt. Thus, this become dt. This become x dot square. So we have here x dot square dt. Then we can since this is order the same, put it outside. It's pretty much just multiply n times, and the square 1 over square root, so it's -2, so negative n over 2. And then we have multiplication of this. This can be put it inside as a summation. And here we go, and we have this as a multiplication of this. Then we have a sum of this, and as we know from basic calculus, this can be converted into an integral. Thus, we have this formula for a probability of going x naught to xn. It's almost like a kinetic energy integrated of kinetic energy over time. Anyway, so we change the measurement from looking at in the reference frame of x to x prime through x plus mu. You can look at, imagine you are this process is happening in a car. You're looking at inside of the car, then is x. But as the car is moving at mu, and you're looking at it from outside, then it becomes x prime, because the boss is moving at mu, and the inside is moving at x, and then that's x prime equals x plus mu. The same process we will assume have similar results as plotting. Just need to plug in x prime to x plus mu on this both location. Since for our case of reference, mu is not a Brownian motion, meaning it is continuous, meaning the derivative is infinitesimally small compared to x. Thus, we eliminate this to 0. Then we can expand this to 3 terms, this and this. Recognize this is just dpx, and here it is. And then we have left with additional term of that, and this is the additional term we have if we have a change of a reference frame, and this can be used for instance, we change a reference frame of a movement, say a change of growth rate of a stock, and we will end up having an additional term as such. And Girsanov, that's a Girsanov theorem.